Hello, we are back in chapter 2.
Deuces.
Geometric reasoning. So this is for all those peeps out there that like to have arguments and win fights. We got some tools for you to use if you want to be a lawyer.
Oh, yeah.
Okay. But before we get started, of course, we need to talk about patterns. So today is all about identifying patterns and finding out what is a counterexample. Kind of like when you're in court and you're like, I counter.
So our learning target, I can identify patterns and counterexamples.
So let's go ahead and take a look at some of those examples below. This is just a starter because obviously you guys know how to identify patterns by now. Math is really just all patterns.
So when I look at that first one, I see it looks like they're listing months, January, and then they skipped to March, though. They skipped February.
January, skip. March.
So skip April, May. So skip the next one, which would be June, and then the next one would be July.
July. You've already paused, right? Because you've tried this on your own. We just make sure that you're interactive here. So 7 times 2 is 14 times 3 times 4 times 5 would be 35 for our next one.
Nice. I just added 7 every time.
Oh, I always thinking easier. Okay.
And then number 3 here, let's see. 1, 4, 9, 16.
I recognize these.
They look like perfect squares to me.
Yeah, this is 3 squared, 4 squared, and
5 squared, which is 25.
Oh, this is that famous pattern. I am going to be so proud of you guys if you caught this pattern. What is it?
Let's see.
What's the name of it?
Fibonacci sequence.
Fibonacci's? Yeah. So
first term is 1 plus the next term.
1 plus 1 is
2.
1 plus 2 is 3.
Yeah.
2 plus 3. Continue that pattern. 13 plus 21 is
34.
There we go. Now we got some shapes. What's happening here?
Ooh, I can use some vocabulary. I see a rotation.
Which direction?
It looks like it's going counterclockwise.
Counterclockwise. That means this way. Then we went down. So if we're going to continue that counterclockwise, we are going to be like bam, shabam, done.
Nice. And then number 6. This is interesting.
1 circle, 2 circles, 3 circles. I got to have 4, and these circles are switching position. So I'm going to have 1, 2, 3, 4. And then enclosed in that is segments.
Nice.
Alrighty. So as we mentioned before, today is about patterns and arguments. In math, we make conjectures. Conjectures are statements that we believe are true. Lawyers do that all the time. Then we have to prove them. We're going to get to that later. This is called inductive reasoning. So inductive reasoning is a 3-step process. First, look for a pattern. 2, make a conjecture, which is the statement you believe is true. Kind of known, would that be kind of similar to a hypothesis? Like
hypothesis,
what you think it is?
Yep.
And then step 3 is prove the conjecture to find a counterexample. So take a look at that or. So either you have to prove it or you got to counter it just like you do in court.
Perfect. And again, to show a conjecture is always true, we're proving it, but we're going to do that in a later section. Today we're going to focus on some counterexamples, proving conjectures to be false.
All right, so just think about that. Today we're going to talk more about proving them to be false. In order to prove something to be false, we have a counterexample. So this is an example which the conjecture is not true. So it's kind of interesting the way that you can display this. Sometimes you can display it with a drawing.
Yep, some sort of picture. Sometimes you can make a statement that simply counters the conjecture.
Or some kind of like numerical value or number or something.
Yep.
Okay. Here we go.
Let's practice some of these. So we can find, for these next few examples, we're going to find a counterexample for each false conjecture. So we're assuming these conjectures are not going to be true, which means there should be at least one example of it not being true. So that first one says every person is a Minnesota Vikings fan.
That is false.
And why is it false?
Because Flynn does not like Vikings.
What?
Mm-mm.
Shame on you. Please don't tell me you're a Packers fan.
No.
Okay, that's good.
To be honest with you, I love all the activities around football, like eating really good food. But, the football itself, meh. Okay.
All right. Let's see. Two complementary angles. Ooh, there's a vocabulary word.
What does that mean? Complimentary.
Complementary angles.
You get a compliment when you are right. And when you are right, they add to
90 degrees.
90 degrees.
So two 90-degree angles are not congruent.
Be careful with that, not. So can you counter that? Can you give me two complementary angles that are congruent?
I think 45 and 45 make 90.
Yes, you're right. 45 plus 45 is 90. So I could just say erase. Okay. 45 degrees.
Yep.
And 45 degrees.
Perfect.
The monthly high temperature in Abilene.
Abilene, yep.
Abilene, okay. Never below 90 degrees for 2 months in a row. Can we prove that false?
Let's see. A bunch of temperatures there. I see 90.
Wait a minute.
But if I go back.
Below. Gotta read directions.
Yep. If we go back to the beginning, right away I saw
90.
88 and 89.
Yeah, so right there I can counter with January and February. Hello, it's the first thing in that chart.
So that's counterexamples, folks. That's all there is to it.
Easy peasy. So let's just go ahead and summarize what we did today for this first lesson. Can you prove a conjecture by giving one example in which the conjecture is true? No.
And
explain your reasoning. Can you prove a conjecture by giving one example is true? Well, I don't know. Let's go up here. Let me guess. Mr. Taylor, did you like the Vikings?
I love the Vikings.
Okay, so that means that we can't prove that it's true just by stating one person.
Yep.
So we could say no. Example 1, Mr. Taylor likes Vikings.
Loves.
Oh,
that's okay. You can say
thought,
like, it's
no,
okay.
I thought that's what you said, and I wanted to draw this, but I didn't want to be like presumptuous. But Mr. Taylor loves the Vikings. Okay. Copy and complete the graphic organizer. In each box, describe the steps of inductive reasoning. Well, first off, we have to identify
the pattern.
Oops, not reaching the board here. Secondly, after we identify the pattern, we make a
conjecture.
And is it true? If yes, verify. We haven't done that, or we talked about proving, right?
Yep. Which we'll do that later.
Is there two?
There's not two O's, but we forgive you. It's okay.
Thank you, because that's not going to be the only time. Okay. And then if no, then?
Give a counterexample.
All right. Lesson 1, finito.